So we're in chapter 4, section 4, factoring polynomials. It says part 1, because we're going to spend 2 or 3 days in 4-4. Okay? So this is just the first day, so it's part 1. We factored polynomials last semester, correct? Polynomials of the form ax squared plus bx plus c. Y'all remember that? Hopefully. We made our x puzzle, put our c value up top, b value in the bottom. We saw what two numbers multiplied to give us our c value and added to give us our b value. Ringing bells? Awesome. So those were only polynomials that had a degree of 2. We call those quadratics. We're going to factor polynomials that have degrees of 3, 4, 5, so on and so forth. Okay? So that's why we're doing factoring pretty much again. So this is pretty much everything I just said, wrapped up in a nutshell. Previously, you factored quadratic polynomials. You can also factor polynomials with degree greater than 2. Some of these polynomials can be factored completely using techniques you have previously learned. So we're still going to use some of those techniques we've learned before. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. That just means we're going to factor until we can't factor anymore. A problem. If we factor it once and we get another factor that can be factored, we're going to factor that. We're just going to keep breaking it down until it can't be factored anymore. Does that make sense?
Sounds like a lot of factoring.
Yes, it does. Any questions so far before we jump into all our examples? You ready for this?
No.
I know Chris is.
I'm not.
Yeah, you are.
No, I'm not.
Okay. Factor each polynomial completely. So like I said, these are going to have degrees that are greater than 2. So for letter A, we have x to the third minus 4x squared minus 5x. X to the third minus 4x squared minus 5x. Does anyone have any ideas what I might need to do just right off the bat? Before I start explaining. Everyone remember how to find a greatest common factor? Guess not. Let's go over it. So, greatest common factor, I'm first looking at all my coefficients. What are all my coefficients on letter A? 1, -4, -5, correct? Is there any number besides 1 that goes into all three of those numbers at the same time? No. So I can't pull a number out. How many x's do they all have in common? 1, right? If I listed this out, x to the third would be x times x times x, right? That'd be minus 4 times x minus 5x. Essentially, you're only as strong as your weakest player. That's how I always describe it. So since this one only has 1x, they only all have 1x in common. Does that make sense? So my GCF in this case is going to be x. So I'm going to factor out a GCF right off the bat. Anytime you have a greatest common factor, go ahead and factor it out. Most of the time that's going to help us in the long run. Now, when I factor out a GCF, I've got to see what's going to go inside my set of parentheses. So I'm asking myself, x times what would give me x cubed? X squared. X times what would give me negative 4x squared? Negative 4x. And then x times what would give me negative 5x? Negative 5. Any questions how we just did that? Not too bad so far, right? So remember, we want it to be completely factored. Can anything else be factored in this case? Using previous techniques or anything like that? Can I factor x, or can I factor x squared minus 4x minus 5? Well, I know for sure I can't factor x. But I can factor x squared minus 4x minus 5. A quick way to check that is you could ask yourself, do I have two numbers that would multiply to give me negative 5, add to give me negative 4? Do I? First off, do I need to slide and divide? Y'all remember slide and divide? Slide and divide is when I have a number other than 1 in front of my x squared. So my leading coefficient is greater than 1. Do I need to slide and divide here? Nope. What's my variable I'm dealing with? X, so I fill that in my two parentheses. I fill in my x puzzle. What goes up top? Negative 5, my c value. What goes in the bottom? Negative 4, my b value. Once again, looking for two numbers that multiply to give me negative 5, add to give me negative 4. Someone tell me what they are. Negative 5 and positive 1. Right? Negative 5 times 1 gives me negative 5. Negative 5 plus 1 gives me negative 4. So I can then fill that in my parentheses. Now, can anything else be factored? No, it cannot. So there would be my answer. Completely factored. Any questions on letter A? Remember, just keep factoring until you can't factor anymore. Can I erase and move to letter B? We all write this down. Letter B. What do I need to do first? Greatest common factor. Do I have a number besides 1 that goes into 3 and 48? 3. 3 goes into both 3 and 48. How many y's do they have in common? 3. So I get y to the third. That's a terrible 3. There we go. So 3y to the third is my GCF. 3y to the third times what would give me 3y to the fifth? Y squared. 3y to the third times what would give me negative 48y cubed? Negative 16. Very good. Does everyone see that? Can anything else be factored? See some people shaking their heads no. Any yeses? I guess there's no yeses. This can be factored. Y squared minus 16. Does anyone recognize what that would be? This would be the difference of two squares. Does that kind of ring any bells? Okay. First off, I still need to account for that 3y cubed. A difference of two squares is when I have two perfect squares being subtracted from each other. Y squared is a perfect square because I can take the square root of it and get a nice whole number. 16 is also a perfect square because I can take the square root and get a whole number, right? And they're being subtracted. So this is the difference of two squares. To factor it, get my two sets of parentheses, and I'm essentially just taking the square root of both of my terms. So what's the square root of y squared? Huh? Y. So that's going to go in the first part of each set of parentheses. What is 16 squared? 4. That's going to go in the second part of each set of parentheses. Do we remember what our signs are? They both subtract?
Yeah.
Close. One's plus, one's minus. Now, can anything else be factored?
No.
No, it cannot. There's my answer. Any questions there? So if you get something that looks similar to that, see if you can take the square root of both terms. If you can, then it would be the difference of two squares. Questions on B? Can I erase and move on? Letter C. 5z to the fourth plus 30z to the third plus 45z squared. What do I need to do first? See if there's a GCF, a greatest common factor. Is there a number that goes into all three of those, 5, 30, and 45? 5 goes into all three of those. And then say it again.
Z squared.
Z squared, because they all have two z's in common. Everyone got that? 5z squared times what would give me 5z to the fourth? Z squared. 5z squared times what would give me 30z squared? Or z cubed, I mean. 6z. 5z squared times what would give me 45z squared? 9. Everyone good factoring out a GCF? Any questions on it? Do you feel confident doing a GCF on your own? No? At least you're honest. Can anything else be factored? Yes. Z squared plus 6z plus 9 can be factored. Once again, do not forget about that 5z squared. Do I need to do slide and divide here? Nope. What's the variable I'm dealing with? Z. And filling in my x puzzle, what goes up top? And the bottom. Looking for two numbers that multiply to give me 9. Add to give me 6. What are they? Positive 3, positive 3. So I fill those into my parentheses. Is there another way to rewrite that?
Z plus 3 squared.
Z plus 3 squared. So my final answer would be 5z squared times z plus 3 squared. Any questions on letter C? Everyone good with that? Can I go ahead and move on? All right. So we just saw an example where we had the difference of two squares, correct? We had a squared minus b squared equals a plus b times a minus b, correct? That was letter B. Back whenever we did difference of squares, did we have a sum of squares formula? See someone shaking their head yes. Does anyone remember hearing me say sum of two squares? We do not have a formula for the sum of two squares. Just for the difference of two squares. However, we do have a formula for the sum of two cubes as well as the difference of two cubes. So I definitely have these written down. Let's go ahead and write these down in your notes. Back whenever we did our formulas with factoring, I told you could either use the formulas if you wanted to or just factor like normal, right? Well, when we're dealing with our cubes, it's going to be a lot easier to use the formulas. I'm just telling you right now. Okay? So make sure we have our formulas written down.
Okay.
Is that a cubed plus b cubed?
Yes. That's a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Then down here, a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Make sure you have those formulas written down. So something to recognize may make it a little easier to maybe remember these formulas. If I have a sum of two cubes, we have the same sign right there, and then we have the opposite sign right there. Same thing with the difference of the two cubes. We have the same sign, opposite sign. That last one will always be positive for these two formulas. Always be a plus sign. So it follows kind of the same pattern. So over here we have two examples. We have 64x cubed plus 1. So to get to our a value, they just took the cube root of 64x cubed to get 4x. Does everyone see that? So your a value is 4x in this case. They did the same thing to get their b value. Took the cube root of 1 to get 1 as our b value. And then you just plug a and b in to your formula over here to get that right there. Does everyone see that? Same thing down here. Cube root of 27x cubed is 3x. Cube root of 8 is 2. Plug your a and b value into your formula to get that right there. Any questions on that before we get into our own example? We tired today? I can tell. Can I move on to our example? We all got these formulas written down? All right. Letter A, factor x cubed minus 125. So first off, I have to decide if that actually is a difference of two cubes. I have to find out if I can take the cube root of x cubed and I can take the cube root of 125. Are those both perfect cubes? Not perfect squares, perfect cubes.
Yes.
Yes, they are, right? I can easily take the cube root of x cubed and the cube root of 125. So I'm going to be using the difference of two cubes formula. A minus b times a squared plus ab plus b squared. That's just straight from the other slide. The hardest part about using these formulas is finding your a and b value. The rest of it's just plugging in and simplifying. So do you all remember how we find our a value? Cube root of what? Of x cubed, right? So what would the cube root of x cubed give me? X. So my a value is x. How do I find my b value? Cube root of 125. We'll handle the negative whenever we're plugging into our formula. Anyone know the cube root of 125? 5. So my b value is 5. So now that I know my a and my b value, I can just plug those in to this formula right here. So I get x minus 5. Plugging in x for a, I get x squared. a times b, what's x times 5? What's x times 5? 5x. And then b squared, what is 5 squared? 25. There'd be my answer. Any questions on letter A? Yes?
How do you know which formula to use?
So in this case, I know I have two perfect cubes, correct?
Mm-hmm.
And it's got the minus sign in the middle.
Oh,
So that's the difference of the two cubes. So I know to use the difference one. Now if that was a plus sign, I would have used the sum of two cubes. Questions on A? Can I erase and move to B? All right. We need to first see if we can even use our cube formulas. Is 16s to the 5th a perfect cube? It is not, is it? I can't take the cube root of it. Is 54s squared a perfect cube? No. What might I need to do first? What did we do at the very beginning of class? Find the greatest common factor and factor that out, right? So, what would be the biggest number that goes into both 16 and 54?
8.
Does 8 go into 54? No. Does 4 go into 54?
2.
2. Yeah? How many s's do they have in common?
2.
2. So my GCF is 2s squared. 2s squared times what would give me 16s to the 5th?
8s.
8s cubed. And then 2s squared times what would give me 54s squared? 27. Does everyone see that? Any questions on it? Can I factor anything else any further? What can I do? The what?
The x.
The X puzzle?
27 on top, or was it 8 on bottom?
Not quite. This isn't in the form ax squared plus bx plus c, is it?
Can you take the perfect cubes?
Yeah. Can I take the cube root of 8s cubed? Yep. Can I take the cube root of 27? So this is a sum of cubes, right? So I can just use my sum of two cubes formula. So a cubed plus b cubed equals a plus b times a squared minus ab plus b squared, right? How do I find my a value? Cube root of 8s cubed. What would that give me? 2s. So my a value is 2s. How do I find my b value? Cube root 27. What does that give me? 3. So my b value is 3. Now I'm just plugging in my a and b value to this formula up here. Don't forget about your 2s squared though. I have to keep that with my answer. It just comes along with me. Then I have 2s plus 3. When I plug 2s in for a, do I plug it in like that? Or do I have to square both the 2 and the s? I have to square both of them. So don't do that one right there. I've got to square both the 2 and the s. So 2s squared would give me 4s squared minus, what's 2s times 3? 6s. And then b squared, what is 3 squared? Three squared? 9. Here would be my answer. Any questions on B? We okay with those?
Oh, you already solved it.
Do what?
You just solved it. You didn't like plug it in.
Yeah, I plugged in my 2s for A and my 3 for B.
Yeah, but then you solved it. So.
Yeah. I didn't show my step of plugging in. Sorry. I was just kind of plugging in as we went. Questions on B? Can I move on? We have one more concept for today. Factoring by grouping. Make sure we're all awake. For some polynomials, you can factor by grouping pairs of terms that have a common monomial factor. The pattern for factoring by grouping is shown below. So I'd make sure I have this pattern down here in my notes with factor by grouping next to it. That way I have an idea of what factoring by grouping looks like. So I'd make sure I wrote that down in my notes. Okay? So we have RA plus RB plus SA plus SB. So essentially, we're just grouping our first two terms together and factoring out a GCF. Our GCF in this case is R. So I factored out an R. I grouped my last two terms together and also took the GCF of those two terms. GCF in this case was S. So I factored out an S. Does everyone see that? Now if you notice, after I did that, I have two things that match up. I have two A plus B's, correct? So I'm essentially factoring out another GCF from there. Because what do they both have in common? A plus B, right? So I can technically factor out an A plus B. And then the two terms that go with it are R plus S. So our two factors would be R plus S times A plus B. Does everyone see that? Everyone ready to see an example with actual numbers in it and variables? Okay. Factor z cubed plus 5z squared minus 4z minus 20 completely. This is our last example. Z cubed plus 5z squared minus 4z minus 20. First off, do I have any GCFs over all four of my terms? I don't. I don't have a number that goes into 1, 5, 4, and 20 besides 1. They also don't have any z's in common, do they? No, so I can't factor anything out. It does look like, however, my first two terms would have a common factor, so I'm going to group those together. And it seems like my last two terms are going to have a common factor as well. So let's find the GCF of both of those groups. So looking at my first group, what would my GCF be of those two terms? Z squared. Does everyone see that? Z squared times what would give me Z cubed? Z. Z squared times what would give me 5Z squared? Everyone good with that part? Everyone with me? Now let's find the GCF of our second group. What would the GCF be of my second group? Negative 4. Why did you say negative 4 and not positive 4? It is negative 4. Negative 4 times what would give me negative 4z? z. Negative 4 times what will give me negative 20?
Plus 5.
Positive 5. Do I have two things that match up now? So what's one of my factors? Z plus 5. What's another factor?
Z squared.
Z squared minus 4. Does everyone see that? The thing that they have in common is one of our factors, and then our GCFs combined together is another one of our factors. Can anything else be factored here? Do I have a difference of two squares anywhere? I do, don't I? I've got a perfect square in z squared. I've got a perfect square in 4. So that's a difference of squares, right? So I can take that a step further. What's the square root of z squared? Z. What's the square root of 4? 2. One's a plus, one's a minus. Does everyone see that? Now make sure whenever you're factoring by grouping that you get something to match up like we did here. My last Algebra 2 class tried to factor out a positive 4. So they got plus 4 times negative z minus 5. So you got to be careful what you're factoring out. Does that make sense? Okay, any questions on that? Can I move on to our assignment? Page 194, numbers 6 through 30 evens. Get this written down for me so I can get the book page projected up onto the board. Get this written down. This will be due Thursday the 14th on Canvas. I know I feel like I've been giving you guys a lot of work, but I feel like I've been spacing it out to make it fair enough for you guys. Because I've been giving you a couple days for each assignment, right? Is that fair? Are there any questions before I end the recording?